In this example, we are going to be taking the derivative of this function, and we call this one a tower function because you have a variable raised to a variable. So that definitely complicates what we got to do. And then once we find its derivative, we find its slope equation, we're going to find that slope at pi over 2. So it's pi over 2 because we have kind of a trig value thrown into it. So pi over 2 is going to be a reasonable value. So let's go through the hard part of this is how do we do a derivative of a power raised to a power? So let's rewrite this. And so surprisingly, we are going to bring in logs basically into that. And it's all about the fact that a log doesn't keep an exponent. And so we have a property with logs that if you have some sort of a value that has an exponent attached to it, you can rewrite it by pulling that exponent in front. Now I bring that up because we can use this property to help us. We just don't have a log yet. So we're going to introduce a log. We're going to log both sides. So we're not going to do much with this. We are just going to log it. And we're going to pick the natural log because we get to pick any log we want. So we're going to natural log both sides. So if we natural log this, we just created that property. And by creating that property, that means that we can take whatever exponent we have and we can pull it in front of the log. Right? So we'll rewrite that. Log, our natural log of f of x equals sine x times the natural log of x. All right. So we're going to do the derivative of this. So what complicates it is we just now created something we have to do on the left side as well. So we're going to do the derivative of the natural log of f of x. So the property is still the property. So when we're doing a derivative of a natural log, it's just going to be 1 over whatever that piece is, and then times the derivative of that. So when you have f of x, it's going to be 1 over f of x, so 1 over the original, times the derivative of that. So eventually, this is what we're looking to get by itself. So we'll have to pull that piece back over on the other side. Okay, but we'll get to that. What we need to do is the derivative of the right side. And we have a product rule that we have to do. So we're going to do the derivative of the first times the second. So that's the derivative of the first times the second plus first times the derivative of the second, which is going to be 1 over x. Right? So we still are trying to get this by itself. So there's our slope, there's our derivative, our f prime. But we have this 1 over f of x that we need to take care of. So we're going to take this on this side. We're going to multiply it essentially to the other side. All right, we're going to multiply that piece over. So that way it cancels on that side. We're left with f prime of x equals, and let me just maybe sneak it in the front, f of x times this. So cosine x natural log of x, and then I can make this sine of x over x. All right, almost there. The last little bit we have is we don't want just f of x in our equation. We do know what f of x is equivalent to, so we can replace f of x with what we started with. So our slope equation is going to be x sine x, x to the sine x, of cosine x natural log x, and then plus sine x over x. And that is our slope equation. Okay, so if we want to evaluate it at pi over 2, we're going to be plugging in pi over 2. So we're going to do f prime pi over 2. So we'll do pi over 2 to the sine of pi over 2 times cosine pi over 2 times natural log of pi over 2 plus sine of pi over 2 divided by pi over 2. Okay, so we got a lot of little pieces to go. So I need to figure out some trig stuff to this. So I need to, what am I going to get when I do sine of pi over 2, cosine of pi over 2? You can pull that information from a unit circle. I like to think of it as graphs. Here's the sine curve. Here's the cosine curve. And then this repeats itself every 2 pi. So this value is pi over 2. So for sine, I get a 1. So we're going to get pi over 2 to the first power times cosine of pi over 2 is this value. So that's 0. So 0 times, doesn't even matter what that becomes, plus sine of pi over 2 again is 1 over pi over 2. All right, so we got some cleaning up to do. So this is going to go away. We're left with pi over 2 times 1 over pi over 2. So I'm going to multiply the reciprocal, which becomes that. So instead of dividing by pi over 2, I'm going to multiply by its reciprocal. So 2 pi over 2, or 2 over pi. And then we got a whole lot of things that will cancel out. So the pi's will cancel, the 2's will cancel, and we get a value of 1. And so that was doing a derivative of what's called a Tower function. We have a variable to a variable. We have to bring in logs in order to do it. And then we can kind of work through the math on that.